So in this video, we're going to look at factoring a difference of squares. In particular, we'll start with using an example like x squared minus 9. So what makes this a difference of squares is that the first term and the second term, or the last term, are both perfect squares. X squared is the result of x times x, and 9 squared, or 9, is the result of 3 times 3, or 3 squared. And it's a difference because of that subtraction sign. So when we factor a difference of squares, there is no middle term. And that's because the two terms, you remember the outside and the inside of FOIL, those cancel out. So it's a simple process to factor. There are two factors. The first term comes from x times x. The last term comes from 3 times 3. And in order for them to cancel out, we make one positive and one negative. Now just to show that, x times x, our first terms, is x squared. Our outside terms are negative 3x. Inside terms are positive 3x. And the last terms, positive 3 times negative 3, is negative 9. And you'll notice that negative 3x and positive 3x cancel out. So we're left with x squared minus 9. So my factors are x plus 3 and x minus 3. The square root of x squared, the square root of 9, and make one positive and one negative. And that applies to all differences of squares. So let's take a look at another one. In this case, we've got 16c squared minus 25a squared. 16c squared, perfect square, good. 16 and c squared. 25 and a squared, both of those are perfect squares as well. So we can go straight to the factors. Two sets of brackets. We know they're going to be two binomials. The first term of each bracket have to multiply together to make 16c squared. So basically we're looking at the square root of 16c squared, which is 4c and 4c. For the last term, they have to multiply together to give 25a squared. So the square root of that is 5a and 5a. We make one positive and one negative, which means the inside, the middle two terms that aren't written here, cancel out. That's it. One more is a good example here. Let's go with something like this. We've got 7g cubed h squared minus 28g5. Now, there's nothing perfect square about 7. There's nothing perfect square about something cubed, or any odd exponent for that matter. But if we can pull out a GCF, a greatest common factor, then maybe, because there's only two terms, maybe we'll get a difference of squares out of that. So 7 and 28, I can for sure pull out a 7. The smallest value of g that's here is g cubed, so I can pull that out. And that's going to leave us with h squared minus 4g squared. And that's a difference of squares. So the factors, this initial one, so sorry, got distracted there. As I was saying, 7g cubed is the common factor, so that gets written once out in front. And then our two sets of brackets again. Square root of h squared is h. Square root of 4g squared is 2g. One's positive, one's negative. And it doesn't matter if you write negative first and then positive, that makes no difference. Okay, easy as that. So on to the next one. And we'll run out of video time here, so we'll do the next one on the next video, which will be factoring number 5, I think. Okay, bye-bye.